Hello and welcome to Water Quality. In this video, I'm going to show an example problem where we calculate the solubility of stannous fluoride, and we're going to calculate it in a lightly salty solution where the salt is sodium fluoride. And in the last video, I calculated the solubility of deionized water, so we'll use this one as a comparison. Okay, first of all, I've shown the reaction for stannous fluoride, precipitation and dissolution, as well as the equilibrium constant. And here we have a lightly salty solution of 10 to the minus 4 moles per liter sodium fluoride. I've drawn these two schematics over here. These are actually the same beaker, just separated by a time step. So initially we have sodium 10 to the minus 4 and our fluoride of 10 to the minus 4 in a deionized water. So we're kind of assuming that we make this solution. I can write this up here in deionized water. So we start with deionized water and add in the 10 to the minus 4 moles per liter sodium fluoride. When we start with that solution, we're going to add the stannous fluoride and then look at how much we can add until we reach the solubility limit, where no more of the salt dissolves into the solution, and any additional salt added is going to stay solid and it will form a precipitant in the solution. And so here, all of the stannous that's added to the solution is coming from that addition, but the fluoride is going to be 10 to the minus 4 plus whatever's added. I could write that as fluoride added. I like to use subscripts. And here we have to remember, because there's 2 fluorides for every stannous, the fluoride concentration is going to be, I should write added here, is 2 times the stannous. And what this means is that the fluoride is going to be 10 to the minus 4 plus 2 times the stannous. So we'll solve this problem using a mass action equation, but I'm going to go ahead and look at ionic strength effects here. And so we'll do that. And so we're assuming 25 degrees Celsius for the temperature, but let's go ahead and include ionic strength effects. So to do that, the first thing I need to do is to calculate the ionic strength. So the ionic strength is mu, which is 1/2 summation C Z squared, and we sum this for the I species. So for this solution, that is going to be 1/2 times the quantity, 10 to the minus 4 for the sodium, and that has a +1 charge, plus 10 to the minus 4 for the fluoride. Oops. For the fluoride that is added, and that's a -1 charge. So this is the sodium, that's the fluoride initial. And then we also need to include the stannous fluoride being added. So I'm going to estimate that using the concentrations that I solved in the deionized water solution. So just as an approximation, I'll start with those previously calculated values, and then we can check at the end of the problem and decide if we want to iterate the solution or not. Okay, so I'm going to use for stannous, for deionized water, I had 10 to the minus 3.11, and this is a +2 charge, plus the fluoride is 10 to the minus 2.81, that's a -1 charge. There. Okay, so I'm going to make a So over here, I want to make a note. That's the stannous, and that's the fluoride. And approximate concentrations using DI water solubility. Okay. And so when I do that, I get a mu value. Let me see, where's my mu? Okay, 0.0024. Okay, so the next step is to get the activity coefficients. And I use figure 3-4 in the textbook Water Chemistry by Snowy and Jenkins. And using that, I get a gamma for species that have a plus or minus 1 charge. So this is the Guntelberg approximation of 0.95, and a gamma for plus or minus 2 species of 0.82. So both of these are Guntelberg effect approximations. And then we'll solve for our solubility using the mass action. And here I'm going to use a KSO for the Stannis, and I'm using activities, not molar concentrations, because we're considering ionic strength effects. And then I'll replace those with gamma times the molar concentration. And I had to remember to square my gammas. I square my gamma and the molar concentration there. And so I'll use the KSO of 1.8 times 10 to the minus 9 that's given. The Stannis, that is the gamma Stannis, we'll use 0.82. Stannis is our variable. The fluoride we'll use 0.95, and that must be squared. And then for the fluoride concentration, we're going to use what we have over here, and that is 10 to the negative 4 plus 2 times the Stannis. And this whole quantity has to be squared. So you can go ahead and put that in your solver and your calculator if that's handy for you. Another option is to solve it using a quadratic equation. I like to use my calculator. And I get a solution of 10 to the minus 3.12. And for the fluoride, which is 10 to the minus 4 plus 2 times the Stannis, I get 10 to the minus 2.82. And these are both moles per liter. And so that is my answer right here. The solubility of stannous fluoride in a solution of 10 to the minus 4 moles per liter sodium fluoride. So what you should see in DI water, our solubility was 10 to the minus 3.11, and so the solubility did go down slightly as a result of the ionic strength going up. Okay, so let's go ahead and write a summary over here. And so in DI water, solubility was 10 to the minus 3.11, and then in this 10 to the minus 4 moles per liter sodium fluoride, solubility is 10 to the minus 3.12. And so as the ionic strength went up slightly, the solubility went down. Now we did make an assumption here at the beginning, and what you should see, or what you can calculate, is that our estimate is less than 5% off. So generally I would consider that to be an acceptable assumption. But if you wanted to, you could iterate to find a more exact solution. So what that means is that you would take your answers here, 10 to the minus 3.12 and 10 to the minus 2.82, and put them back up into your ionic strength calculation, and then resolve the problem until your answers converge to whatever your level of desired accuracy, I suppose. But in this case, for me, they're within 5%, so I'm okay. We can see that the solubility went down as the ionic strength went up. And so in the next problem, what we're going to do is to investigate solubility in a saltier solution so we can verify this result.